Chapter 1, Section 1, Patterns and Inductive Reasoning. So we're going to start with a few definitions. First of all, inductive reasoning is reasoning based on patterns that you observe. A conjecture is a conclusion you reach using inductive reasoning, and not all conjectures are true. A counterexample is an example that shows a conjecture is incorrect. Alrighty, so for patterns, 3, 6, 12, 24, ... So what comes next? Well, to go from 3 to 6, that's 3 apart. 6 to 12, that's 6 apart, that's 12 apart. So it's not just adding the same number every time. Let's see. But it's doubling. So let's see, the pattern is times 2. I know, I just used an X for times. Don't tell my math teacher. And next up, the next couple numbers, well, 24 times 2 would be 48, and 48 times 2 would be 96, and so on and so forth. All right, on example B, we have a circle with 1 line through it. Then we have a circle with 2 lines through the center. Then we have a circle with 3 lines through the center. And I'm noticing also that the lines, they go through the center and the pieces are even. So the pattern would be plus 1 line through center, through the center, to make even sized, or equal, there we go, equal pieces. Oh dear, now we get to trust to my drawing ability. So the next piece, or the next thing needs 1, 2, 3, needs 4 lines. So 1, 2, 3, 4. Oh dear, and the one after that needs 5 lines. I don't think I'm going to be able to draw this evenly, but let's pretend. 1, 2, 3, 4, 5, and we're going to pretend that those are all the same size. So now I have a do-it-yourself for you. DIY stands for do-it-yourself. I want you to find the pattern and write the next 2 entries. And same thing here, find the pattern and then write the next 2 things that would be in the list. Okay, now let's use some inductive reasoning. So, make a conjecture about the sum of the first 30 odd integers. Well, 1 equals 1. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7, 9 plus 7 is 16. I'm noticing something actually really kind of surprising. 1, 4, 9, and 16 are all square numbers. So we've got 1 squared, we've got 2 squared, we've got 3 squared, we've got 4 squared. You'll notice this is the first odd integer. These are the first 2 odd integers, the first 3 odd integers, the first 4 odd integers. So my conjecture is that the first 30 odd integers will equal 30 squared, which would be, what would that be? 900. The sum of the first 30 odd integers is going to equal 900. That's my conjecture. So, assuming that my conjecture is correct, your do-it-yourself is to make a conjecture about the sum of the first 35 odd integers. Oh boy, counterexamples. Counterexamples are fun. They're, okay, you know how little kids like to argue? At least in the US, they love to argue. And they'll do it forever. Like, I don't know, they'll argue about stupid stuff too, like, you have more than me, Nuh-uh, yeah-huh, nuh-uh, yeah-huh. And they'll do that over and over and over and over. And it never really goes anywhere. So a counterexample is where you actually want to go somewhere with your with your argument. So instead of just saying nuh-uh, you say nuh-uh because, and your counterexample is proving that the conjecture is wrong. So I'm going to find some nuh-uhs here. The square of any number is greater than the original number. Ooh, nuh-uh. I've got a couple of these. How about 1/2? 1/2 squared is 1/2 times 1/2, which is 1/4. And 1/4 is not bigger than 1/2. Okay, so there we go. Voila, my counterexample. Nuh-uh, because 1/2 squared is not larger than 1/2. Next up, you can connect any 3 points to form a triangle. Ooh, I know that a triangle needs 3 points, so if there is a counterexample, I've got to think of 3 points that don't make a triangle. Ooh. Okay, let's see if I can draw 1, 2, 3. If my 3 points are all on a line, I guess I shouldn't dot those because it makes it look like my points. If my 3 points are all on a line, I can't make a triangle out of them. So there's my counterexample. So if you could, for yourself, find a counterexample for a number is always greater than its reciprocal, and little research project, if you don't know what a reciprocal is, you can Google it real quick. And if a number is divisible by 5, then it is divisible by 10. So do better than a little kid. Don't just say nuh-uh. Say nuh-uh because, and give us an actual reason. By the way, yaha and nuh-uh is little kid language. Grown-ups don't usually use those words.